All right, everyone, welcome back to homework section 4.2. And just a couple things before we get started with this homework assignment. I am going to hopefully help us remember that there are two forms of linear equations that we tend to be working with. The first is the one we like, which is slope-intercept form. And that is y equals mx plus b, where m is the slope and b is the y-intercept. We'll talk more about that as we do today's homework. The other is point slope form. And one thing to remember, folks, is if we have a y-intercept, we want to use slope-intercept form. And if we have no y-intercept, we will need to use point slope form. So just a quick refresher again, point slope form is y minus y1 equals m times x minus x1. And in this one, m is also the slope, just like it is in point slope form. The difference being that we don't have a y-intercept, we have a different point that is not the y-intercept, which is where the x1 and the y1 come from. That's the x value and the y value from that other point. So we're going to go ahead and be needing to use point slope form in this first one because we are asked to create an equation for a line, and we are given the slope, which is 5/4, and we are given a point, but it is not the y-intercept. So we are given a point and a slope, so we do need to use point slope form. So the way we do that, folks, is we sling our y minus y1 equals m times x minus x1. And in the case of this one, we can just pull things directly from the problem. This right here is our slope. And we can label these points x1 and y1. So I'm just going to substitute those things into the equation, and we'll see what happens. So we will have y minus, our y1 is 3, equals our slope is 5/4. And then we have x minus x1 is 8. So that is a valid equation that represents this line. It is in point slope form, though, and we are asked specifically to write the equation in slope-intercept form. So we basically just need to solve what we have for y. And so the way that I'm going to do that is multiply on the right side, do my cleanup. And so I will be having y minus 3 equals 5/4x. And we do have a positive 5/4 times a negative. So positive times a negative is going to make a negative answer. 5 times 8 is 40, divided by 4 is 10. So all that's left for me now, folks, to solve for y is to go ahead and add 3 to both sides. And I need to remember my rules about positive and negative numbers. So let's get to that right now. Y equals 5/4 x. I have a negative and a positive. So the signs are different. I need to find the difference. The difference is 7. And I put the sign of the bigger number. 10 is bigger. It's negative. So our answer is negative. So for this one, folks, we are going to have y equals 5/4x minus 7 as the equation, and it doesn't ask for a graph, but I'm going to go ahead and make one anyway just to kind of show what this would look like if we were to graph it. And what we would end up with is we would have a point down here at the y-intercept 0, -7, and we would be having a slope of positive 5/4. So to get to the next point, we would go up 5 and to the right 4. That would put us there, and that would make a line that looks something like that. Just a quick sketch to show you the relationship between the graph and the equation that we have there. So I'll pause for a moment before moving on to part B. Okay, part B is much easier. We are given an equation in slope-intercept form, and we can remember that that is the slope and that that is the y-intercept. And so all we are asked for in this case is the slope and the y-intercept. Here the slope is -1/5, and the y-intercept is +7. So that's a pretty simple one. Again, I am going to go ahead and sketch a quick graph just to model this and try to draw a comparison among this a little bit. So We would have a y-intercept of positive 7, so we would end up here at 0, 7. And our slope would be negative 1/5, so we would go down 1 and to the right 5. So it would look something like that, and we would end up with a line that looks like that. Okay, folks, so that's going to be it for number 1. I'll pause for a moment here before I move on to number 2 so that you can pause and take notes if you need to. Okay, on to number 2. We have an equation whose slope is negative 1/2 and y-intercept is negative 3. So this is going to be really darn easy for us, folks, because we know that we can use slope-intercept form. Because we are given a slope and a y-intercept, so that's y equals mx plus b. And my m is my slope, and my b is my y-intercept. So I can take that information directly from the problem. I've got a slope of negative 1/2, and I have a y-intercept of negative 3. So I'm just going to substitute those values into the problem. And so we will get an equation that looks like y equals negative 1/2 x minus 3. And another way to write that, folks, I'm actually going to do a little bit differently. I'm going to say plus a negative 3 because I think a lot of people think about it like that, like I'm going to add my y-intercept. And that's totally okay, but it is a good idea to clean up these signs that are next to each other. So an alternative way and the more correct way to write this would be y equals negative 1/2 x minus 3. Okay, and I'm not going to do a graph for this one because that's actually what the next problem is asking us to do. So we are going to be graphing this problem. And so we will start with our y-intercept. So we will come down to negative 3. And we will see that we have a slope of negative 1/2. So that tells me to go down 1 and to the right 2 for my slope. And so I'm going to do that repeatedly. And I would have a line that would look something like this. Okay, that's it for problem number 2, folks. I'll pause for a moment and then move on to number 3. Okay, we've got number 3 happening here. We have an A and a B, which is great. Okay, so let's take a look at this, folks. We are asked for the y-intercept and the equation of this one. So I can see that we were given the y-intercept here. It's right there. So since we have the y-intercept, we can use the equation y equals mx plus b for this one. And so again, remember, the m is the slope, and the b is the y-intercept. So my equation is going to be, I need the slope and I need the y-intercept. So the y-intercept is 4. And the slope, if I go from this point, the black one here, down to the blue one, I would go down 1, 2. So I have a slope of negative 2, and I would go over 1, 2, 3, 4, 5. So I would have a slope of negative 2 over 5. So my equation would look like y equals negative 2 over 5 x plus my y-intercept, which we've already identified to be 4. So my equation again, folks, is y equals negative 2/5 x plus 4 because my slope is negative 2/5 and my y-intercept is 4. I'll pause here before moving on to part B. All right, then, so for part B, we have a little bit more tricky situation going on here. We are not given the y-intercept, and you can tell there as you look at the graph that it doesn't cross at a whole number. So again, anytime we are not given the y-intercept, we need to use point slope form. Which is y minus y1 equals m times x minus x1. And so what we're going to need for this problem, folks, is to identify the slope, which is m. And we need to identify an x1 and a y1. So I'm going to go ahead and name these on the grid. This point right here is the 0.26, and this point here is the 0.52. So I could choose to have either one of those be my x1 and my y1. Just depends how I choose to name them. So I'm going to go ahead and name them x1, y1, and x2, y2. So I won't need my x2 and my y2, but I did want to name them just to give you an idea of what they would be named if we chose to name them. So we can go ahead and put that information in. We have y minus y1. Our y1 is 6, equals m, which is our slope. So our slope going from the black dot to the blue dot, our slope is going to be down 1, 2, 3, 4, so minus 4. And over to the right, 1, 2, 3, so positive 3. So our slope is negative 4 over 3 times x minus, and our x1 is 2. So all we've done, folks, between what the first step we had there and this step is to put in our x1 and our y1 values, which we got from the graph, and put our slope in, which we also got from the graph. And so I do need the equation written in slope-intercept form, it says here, so we do need to manipulate this and solve it for y. So we're going to go ahead and do our cleanup work on the right side there, folks, where we will do the distributive property with that negative 4/3. And we will get y minus 6 equals negative 4/3 x. And a negative times a negative makes a positive 8 over 3. And so lastly, folks, the last thing that we need to do is add 6 to both sides. And so I sort of hate the fraction scene, so I'm going to go ahead and just do it up. I've got 8 over 3 plus 6, which is the same as 6 over 1. So I need my 6 over 1 to have a denominator of 3, so I'll multiply them both, the numerator and denominator, by 3, and I will get 18 over 3. So I have 8 over 3 plus 18 over 3, which is going to be the same as 26 over 3. Kind of a crazy y-intercept, but that's okay. Y equals negative 4/3 x plus 26 over 3. And so 26 over 3 is a little bit more than 8. You can tell that because 26 divided by 3 is just a little bit more than 8. And so if we look at our graph, it matches that our line does cross the y-intercept a little bit above 8. And so I think that this is a good final answer right here. Okay, I will pause here for a moment in case you are wanting to use this to take notes, and then I'm going to move on. Alrighty, we have another case here where we're asked, to make to write an equation for a vertical and a horizontal line that pass through the point -3, -1. So I'm going to sketch it really quick just to get an idea of what's going on here. -3, -1 would be like right there. And so I need the equation for a vertical line, and I need the equation for a horizontal line that passes through that point. So if we look at the blue line, that blue line is obviously vertical. And if we look at the values of the blue line, like if we trace it up and down, the y value over there will constantly be changing because you're going up and down, but the x value is always going to be -3. So for this one, folks, our equation is very simply x equals -3. And that's going to be the case for any vertical angle or vertical line where the equation is just going to be x equals something. And similarly for a horizontal line, the x value is constantly changing as we move back and forth, but the y value is always -1. So for a horizontal line, it's always going to be y equals something. And in our case, it's y equals -1. This is probably not something it's going to matter a whole lot as you go forward, so don't try and like burn this into your memory or anything like this, folks. Honestly, I still get these backwards all the time, and I have to draw the drawing to help me remember. So please understand this is not something that you're going to be like heavily tested on, or that's going to be a big deal as you go further along in math. All right, moving on to number 5. I'll pause for a moment first and then go. Okay. So number 5 is also an awesome one. This is a pretty easy one, actually. I'm happy about that. So what is this? Oh, it's not, well, yeah, it is pretty easy. So the slope of parallel and perpendicular lines. Let's talk for just a moment. If we have a line that goes like this, for a line to be parallel to it, it would have to go like that as well. And if another line was parallel to it, it would go like that. And so those are all parallel. And what do we notice about them, I hope, is that you would see that they all have the same slope. They're all behaving the same as you travel along the line. So a line that's parallel to this line will have a slope that is exactly the same. So a line that is parallel, its slope will be -2/5. Okay, and there's a really cool activity you can do to demonstrate what I'm about to show you. But a perpendicular line would have a slope that goes like this. And what you would notice about a perpendicular line, if we were to study it, the slope of the perpendicular line is the opposite inverse. And what I mean by opposite inverse is change the sign. And what I mean by inverse is flip the fraction. So to get a slope that is perpendicular, we simply change the sign and we flip the fraction. So folks, the opposite inverse of -2/5, again, opposite, we're going to change the sign so it was negative. The perpendicular line is going to have a positive slope, and you can see that with my red and yellow lines over there. And the inverse tells me to flip the fraction, so I'm going to have not negative anymore, I'm going to have positive, and I'm going to flip it over. The slope of the perpendicular line would be +5/2. Okay, that's it for number 4 and 5. I'll pause here for a moment and move on to number 6. Alrighty, folks, number 6 is up, and we have the equation -5x minus 9. We are looking for the equation of the line that is perpendicular to this line and passes through the point 3, 6. So the first thing we need to think about is, gee, if it's perpendicular, the slope is the opposite inverse. So the opposite inverse of -5, our slope is -5. So our perpendicular slope would be the opposite of that, so it would be positive because our original slope is negative, and it would be the inverse, so we would flip it over. And so this is really -5/1. We're going to change the sign to be positive, and we're going to flip it over, so our new slope of our perpendicular line is 1/5. And so we need this slope for our perpendicular line, and it has to pass through the point 3, 6. So we have a point, we have a slope. We're going to use point-slope form to figure this one out. So again, point-slope form. Is y minus y1 equals m times x minus x1. And so I'll identify these. The 3 is my x1, the 6 is my y1, and we already identified my slope is a positive 1/5. So we're going to have y minus y1 is 6 equals 1/5 times x minus x1, which is 3. All right, folks, and we're going to go ahead and do our cleanup work, which means that we are going to be doing the distributive property on the right. And so we'll have the 1/5 times x and the 1/5 times a -3. And we will get y minus 6 equals 1/5 x minus 3/5. Okay, and I'm going to have to do a little bit of work around now that I'm going to add the 6 to both sides. I could eliminate the fractions from this equation if I wanted to, but I'm just going to go ahead and do the work of adding these up really quickly. So I will have 6/1 plus 3/5. Sorry, no, my bad. I will have 3/5, -3/5 plus 6, which is the same as 6/1. And I need common denominators, so I need to turn my 6/1 into something over 5. So 6/1 times 5/5 makes 30/5. So I'll substitute that in there. -3/5 plus 30/5. And so I pay attention to my signs. My signs are different. I find the difference between 3 and 30, which is 27. I put the sign at the bigger number. The bigger number is 30. It's positive. My answer is positive. and it's over 5. So I'm going to end up with y equals 1/5 x plus 27 over 5. And that's going to be the equation for that line that is perpendicular to the original line and passes through the point 3, 6. Okay, so the way that would look, let's just sketch it really quick just to have a quick idea and understanding of what's really going on here, folks. We would have negative 5x minus 9 would have a y-intercept that's down here at negative 9, and it would be pretty steeply going in the negative direction. And then if we had our new line that passes through the point 3, 6, it would pass through this point way up here somewhere. And it would be having a slope that's pretty shallow, so not very steep, and it would look something like that. And you can see those two lines coming together form pretty close to, in my sketch anyway, a 90-degree angle, which means that those lines are perpendicular, and where they cross would be right there at the point 3, 6. No, that's not 3, 6, is it? They cross at negative something, so the 3, 6 is actually going to be right there. This point that I used to identify my line in the first place. Sorry about that, folks. So we have one more to go. I'll pause here and then move on. And the last one for us is going to be that we want a line that is parallel to the original line and passes through the point 3, 6. And so I'm going to use my same drawing, and I'm going to draw that line in green. So we're going to be looking for the green line this time. It would have the same slope as the blue line, but would be passing through the point 3, 6, just like the red line is. And so I'm actually going to copy my equation. We have y equals negative 5x minus 9. And so since we want a parallel line, the slope will be the same. So the parallel slope would be negative 5. And we need to pass through the point 3, 6. So we have a slope, we have a point. We need to use point slope form. So again, y minus y1 equals m times x minus x1. And we stick our values in there. So our slope is negative 5. That's going to go in for our m. And we'll call this x1, we'll call this y1. So substituting those in, folks, I get y minus 6 equals negative 5. Just do my parenthesis backwards. Can you tell I'm getting tired? Times x minus 3. And we'll go ahead and do our cleanup work on the right, folks. We will have our negative 5 times our x and our negative 5 times our negative 3. So we will have y minus 6 equals negative 5x plus 15. Finishing this thing off, folks, we are going to have plus 6 on both sides. And we end up with the equation y equals negative 5x plus 21. And so that's how we would do that shindig for a line that passes through the point 3, 6, that it has a positive, a parallel slope to the original line. And you can see with our green line up here, that's what that would look like. Okay, I'm going to leave this here, folks. This is the end of this homework assignment. Thank goodness. I hope this is helpful. I hope you have an awesome day. And I will be back with the next video soon. All my best, everybody.